right, so I want everybody to open up their science books to page 80. Open your book to page 80. Go ahead, Nasir. Good job. Page 80. Good. Okay. Okay, so I want everybody to take their pointer finger and put it on the very top left globe over here, that the picture of the earth that we see. Everybody put it on the very top left one. Jinheng, what do you notice about the earth's land masses in this picture? What do you notice about them? Is that what the earth looks like today? No, not quite. What's different about it, Jinheng? I asked Jinheng. Thank you. It's not the same. What's different though? Do you see a lot of water in between each continent there? Do you see a lot of water though in between here? No, not really, right? So all the land masses are really close together, aren't they, in this first picture? What about, Andrew, in this very last bottom right picture? What did you notice that's different from the very top left picture?
It's farther away.
Yeah. So these pictures, what they show is the movement of the continents, right? So the Earth's plates, the peels, the parts of the peel of the orange, they don't stay in the same place. They move further and further away. And what actually they're doing is the Earth's crust, which is which part of the Earth? Is it the innermost layer or the outermost layer? Which part is it? Outermost layer, that's what the crust is. It's the very furthest outest part. Okay, that part of the Earth floats on top of the second layer of Earth, which is the mantle, right? Which is made of what? It's made of lava and magma, right? So that's why these continents, you see how that they've moved from the very top left picture to the very bottom picture, which is where they are today, right? Good. So I'm going to read our third definition for today. Boundary. Can you say boundary?
Boundary.
Boundary. The place where edges of the continental plates meet. So, Nasir, can you point to me a boundary on our Earth? Where would a boundary be? The place where the edges of the continental plates meet. Where would a boundary be? Good. So right on the edges of each peel is where a boundary is. Good. So can everybody look at page 81 of their science textbooks? Good. So we're not going to read the text. We're just going to look at the picture. So why is it that our Earth's plates are moving? Why are they moving? Look at the picture, and I want somebody to make an inference for me. What does it look like? Why are they moving this year?
Cause the snow.
Snow? What is this?
Lava.
And what is it doing?
Coming. It's cooling down or coming up.
It does cool down. So what's happening in this picture, what this picture is trying to show, is that magma from the Earth's mantle is moving up, right, towards the Earth's crust. And when it does, if my hands here are two different plates, what happens when magma pushes up is it pushes the plates further apart.
Yes.
And then, exactly as Nasir said, that magma cools down and it becomes new crust. It becomes new Earth. So when the magma pushes up from the mantle, the plates move further apart like this, which is just what they're trying to show here in your picture. Yeah, it moves apart, and that's why the Earth's tectonic plates, that's why they move. Good. Okay, so can everybody turn to the next page, page 82? Go ahead and flip it there. So page 82, this picture here is showing you what a boundary is.
It looks like a Z.
A Z? Kind of. It's showing how different parts of the Earth can move in different directions like this. Just like what we noticed with the orange, right? So with the orange, we noticed that sometimes when we push, keep your eyes up here, Sophie and Nasir. Sometimes we notice when we push on different parts of the peel, sometimes this part covers up another plate and it moves further away from another plate too, right? So, if you look on page 83, what happens when it moves apart from another plate is actually a mountain is created. Can you please sit down, Sophie? Thank you. So a mountain is created. So when I push this peel of orange up over here, you see how it's taller? This becomes a mountain on the Earth's surface. And today, we're going to be building a model that shows us how mountains are created. All right? Before we go to our mountain building, does anybody have any questions? What questions do you have? No? Okay. So everybody close your science books, please. Okay. So we're going to be using this to build our models. I'm not answering questions. Hold on. We're going to use this to build our models of our mountains. Okay, so we're going to work in groups. And Andrew and Jin Hang, you guys are going to work together. And can you scoot your chair closer over here, Sophie, please? And Sophie and Nasir are going to be working together. Okay? Good. So, the first thing I'm going to ask you guys to do is Jin Hang and Nasir, can you please thread this paper through the slit in the cardboard? Can you thread this paper through the slit in the cardboard? Actually, it's going to go this way. Thread it this way. Try not to bend the cardboard too much. Perfect. Good work.
Cool.
Yeah, very cool.
I know how to do it.
Good. Okay. Now, so without looking up here, what is the name of the Oops, it's okay. What is the name of the different moving plates that we have on Earth? What are they called? What are they called, Andrew? It's kind of a tricky name. Close. Tectonic plates. Right? Okay, so I'm going to hand each group 2 tectonic plates. And I'm going to ask that everybody put a label.
How did you make this? How did you make this?
I used Play-Doh. So I'm going to ask that everybody please put a label on both of their tectonic plates. Put a label on both of your tectonic plates. On the tectonic plate, which is this, the Play-Doh. Good. Good work. Okay. Now I'm going to come around and tape down one of your tectonic plates to the cardboard. No, we can't.
So you come down here again, we can still do it?
No, I'm going to take it home. But it's okay because you're doing it right now. Can you put your tectonic plate a little bit back? Okay. This is your tectonic plate. Good. All right. Now, who remembers there's a special type of rock, okay? And this type of rock, let me give you the clues first. So this type of rock is made up of mud and sand and pebbles. Good, I see some hands already. I have a couple more clues. The last clue is that this rock takes a really long time to be made. What kind of rock is it, Sophie? Not an igneous rock. What are some... Yes, Nasir?
Mantle.
Not a mantle rock. So what kind of rock? This rock is really special. It's made of sediments and sedimentary rock. Very good.